All right, so here are some notes. If you were gone from basic class on Wednesday, October 3rd, if you were testing or whatnot. So we're just going to go through the electron configuration rules. There's 3 of them. And it ties into what was talked about on Tuesday. You have the principal energy levels and then the sublevels and the orbitals. Okay, so the first rule is that it's called the Pauli exclusion rule. So make sure you write that in for the rule, and then underneath it, put each orbital can hold a maximum of 2 electrons. Now make sure you pause this video if you're not getting everything written down. You can always pause it and then start it back up. So if I'm speaking too fast or whatnot, definitely use that. Okay? So it's saying that each orbital can hold a maximum of 2 electrons. Okay? So over along the side, over here, these are our different sublevels. Right? So remember, in those sublevels, there are different orbitals, and that is what's over here. These are all the different orbitals that fit into those sublevels. Okay? So in each of these orbitals, they can hold 2 electrons. All right? And so 2 electrons can be in that S, and then in each one of the pictures, so in P, each one of these can hold 2 electrons. Okay? So in S, it will hold up to 2 electrons. So S will always equal 2. P, since there are 3 orbitals, it will hold up to 6. D, since there's 5 orbitals, it will hold up to 10. And another thing, you see this picture right over here, and this with the arrows, this represents them spinning in different directions. So when we write out our orbital diagrams, which we'll see in a moment, we'll always use arrows, and we'll always put one going up, one going down in those different orbitals that we have. Okay? So we use Bohr's model to represent it because it's really easy for us to see. All right, and it's not correct, but it's easier. We need pictures. We're visual learners, so we need those pictures. All right, so in Bohr's model, and you probably learned this in junior high, that you realize that in that first energy level, you always had 2 electrons. Okay, in energy level 2, there's 8. This should probably kind of ring a bell. All right, in that third energy level, there's actually 18, because remember, in that first energy level, we always have just S. Okay? In energy level 2, there's S and P. In energy level 3, there's S, P, and D. All right? Remember, in S, there can be 2 electrons. So then in the second one, there's S for 2, P can have up to 6, so 8. In the third energy level, S has 2, okay? P can have 6, D can have 10, so that gives us 18. So that's how many electrons each of those energy levels can have. So we have energy levels, sublevels, we need to keep them all straight. Okay, so how do sublevels actually fit into Bohr's model? Well, this picture, right, it's just one first energy level, there's just one S. Well, 2, there's the 2S, 2P. All right, and then we get into energy level 3, and it's 3S, 3P, 3D, and you notice that 4S actually overlaps. It's just a little bit lower in energy. And there's going to be really cool tools to help you remember these. So don't panic right now. It will be there to help you out. Okay? So the second principle, so this is the second thing you will need to fill in, is called the Aufbau principle. Right? And it just says electrons fill orbitals that have the lowest energy first. Okay, so remember to pause it if you need to. If I'm talking too fast. All right, so our lowest energy level first is down here at the 1s. So we need to make sure that we fill that in first. Once that has its 2 electrons, then we go up to our next lowest energy level, which is 2s. All right, once that's completely filled with electrons, and how many electrons can fit in each of those? Just 2. Then you go to the 2p, and you make sure you fill each one of those orbitals with a max of 2 electrons. Okay? The last one is called Hund's rule, and I state this as the bus rule. All right? Because I know when I ride a bus, I don't like to sit with anybody if I don't have to. So if there's an open seat, I will go take that open seat. All right? So you don't usually want to share with people. So Hund's rule is one electron must occupy each orbital at the same sublevel before doubling up. So what in the world does that mean? All right? Well, in the S, there's only one orbital, so we don't have to worry about that. But when we get into the P's, the D's, we do. We have to make sure that each one of those orbitals gets 1 electron first before we double it up and give it 2. That's all that it is saying. So give it 1 each, and then go back and give it its second electron. That gives it 6. Then once that's filled, then you move on up to the 3s. Okay? So the bus rule. So orbital diagrams, what these are, it just shows us with arrows where these electrons are located. So here we have 1 electron, and that electron represents hydrogen. You found that using your atomic number. So pause the video, take out your periodic table. You're going to need it. All right, hopefully you found your periodic table. If you don't have one, look in your planner. There should be one there. But hydrogen has an atomic number of 1. So it tells us the number of protons and electrons. All right, since it has 1 electron, we just put it in our lowest energy, because that's the Aufbau principle. Okay, and we're done. All right, this is going to be, when we write out the electron configuration, what we put is we put the energy level, which is 1, the sublevel, which is S, and how many electrons we have, which is 1s1. Okay, so this is called the electron configuration. This is its address. Okay, so if we look at the next one, helium has an atomic number of 2. So we put our 2 electrons in, 1 arrow going up, 1 arrow going down. Okay, so when we write out the electron configuration, we're in energy level 1, sublevel S, and there's 2 electrons in that sublevel. Okay, if we keep going, the next one, if we put a third one in there, that is lithium. Okay, the 1s was full. There's 2 electrons, so that means we have to go up another energy level. So that means we're going to the 2s. Okay, so 1s, and how many electrons are in there? There's 2. Okay, so we have to put what we've filled in, and then we go up to the next one, and we're in the second energy level. All right, there's the sublevel S. How many electrons are in there? There's 1. And that's all we do. That's the electron configuration for lithium. Okay, so when you're writing out an electron configuration, all right, you always put this big number first, is a 1. Okay, the sublevel right here is the S would be considered its sublevel if it's S, P, D, or F. And then the 1 stands for total electrons in orbitals of the sublevel. So how many electrons are in the orbitals of that sublevel? Okay, so S can have a max of 2, P can have the max of 6, and D can have the max of 10. Okay, so that is all we covered on Wednesday. If you have any questions, please, please, please come and ask me. And yeah.